Bien, buenos días. El Instituto Politécnico Nacional, a través del Centro de Desarrollo Espacial, le damos la más cordial bienvenida al doctor Kalifa Goïta. Del marco de ciclo de conferencias que se hacen de manera cotidiana en el CDA, temas espaciales. El doctor Kalifa Goïta es profesor titular y responsable del Departamento de Geomática Aplicada e investigador del Centro de Aplicaciones y de Investigación en Teledetección de la Universidad de Sherbrooke, Quebec, Canadá. Su formación en licenciatura es como ingeniero en Ciencias Aplicadas, en el tema de topografía, por la Escuela Nacional de Ingenieros Mali. Actualmente estudia estudios de maestría en teledetección en la propia universidad que hoy se desempeña como profesional. Asimismo, hace el doctorado también en teledetección en la propia universidad, posteriormente un posgrado en teledetección también en Toronto, Canadá. Tiene un amplio desempeño como especialista en sistemas de información geográfica, campos de teledetección, en análisis y estudio de parámetros biológicos y geológicos. Su interés se centra en la teledetección y la geomática aplicada al medio ambiente, los recursos naturales y sus riesgos. En geomática también trabaja en la propagación de los incendios y las inundaciones, minería, aplicaciones astrales y actualización de mapas geográficos. En los últimos años ha participado como coautor en 14 publicaciones, tan 2013 a la fecha, tan solo en 2010 en 8 de estos temas ligados a la geomática y la teledetección. Le damos la más cordial bienvenida al doctor Kalifa Goïta, quien presentará la conferencia Situación actual y perspectivas de la teledetección y geomática en la Universidad de Sherbrooke. Le damos la más cordial bienvenida y la conferencia se va a dar. Bienvenidos y adelante. Una aclaración, el poco auditorio no es que así sea. Hoy en día ya trabajamos con las redes sociales y la gente que nos está viendo a través de YouTube. Adelante.
Okay, thank you very much for inviting me to present academic programs we are doing at the University of Sherbrooke. I would like to do this presentation Spanish, like him, but I cannot. So I will try to do it in English. But we are a French-speaking university. Everything. But I will try to present our work in English. If you have any question, don't hesitate, because I divided my presentation in parts. The first is about our academic programs, how it works, how they work, and the second is the research we are doing. I'm here also with my colleague, Professor Ramata Magaji. We are in the same department, same research center, and we have a lot of research activities together. So where we are, here is Sherbrooke, for people who knows the maps of Canada. We have different provinces, and we live here in we are located here in the city of Sherbrooke, in the province of Quebec. Sherbrooke is, if I take the scales of Mexico here, Sherbrooke is a very, very small city because we are just about 200,000 people at Sherbrooke. And we have two universities. The first one is the University of Sherbrooke with around 25 to 30,000 students. And the second is a small university. It's an Anglophone university, University Bishop. It's a very tiny university with around 1,000 students. So this is our location. Okay. We are small, but we are also a big player in the field of remote sensing, because in our university, the University of Sherbrooke has some specialized fields, and remote sensing is one of these specialized fields among the other universities in Canada. We worked in remote sensing and GIS, and we have the biggest remote sensing center among the universities in all Canada. We have academic programs from the bachelor degree to the PhD degree. I will present all these programs, but the bachelor degree is in applied geomatics, and the PhD is in remote sensing. Our research center was created somewhere in 1985, and I will present also this research center. And we have a lot of collaboration, international collaboration, national collaboration also with different universities in Europe, France, Belgium, and so on, in Africa, Asia, and so on, and here again, here. Okay. Our department started in 1963, more than 50 years. But it started simply as a department of geography. It was first a department of human geography. Okay, in 19. But a few years after, they integrated a lot of scientists in physical geography, in remote sensing, physics, and so on. And the department changed its name in 1988 to become the Department of Geography and Remote Sensing. So the two fields were integrated. And when geography professors retired, the department changed again the name and became the Department of Applied Geomatics. This is the actual name of the department. Okay? And as I said before, the research center itself was created in 1985. Okay. The objective in the department is to offer academic programs. The first one is the Bachelor in Applied Geomatics. This is the official name of this program. And we have also a bachelor program in environmental studies. In fact, we are involved in this program. It is a kind of multidisciplinary program. And the master degree, we have a master degree in geographical sciences. It includes a master degree in remote sensing and a master degree also in geography itself. Okay? And finally, we have this PhD program in remote sensing. It is the only program with this name over Canada, only one. And our second goal is to develop research program in remote sensing and geomatic graphical science. And of course, to promote the use of geospatial technologies. It is one thing to train people, but it is the other thing to show them how to use these technologies in the industry and so on, every day. Okay. The department has 12 research professors. We have several adjunct professors. The adjunct professors are researchers who are working in government or the industry or they can come also from outside Canada, from different provinces of Canada. For example, if someone like Alexandro want to be adjunct professor of our university, that is possible. Have a number of criteria, and many researchers can ask to become an adjunct professor or be habilitated to supervise students at the master or PhD level. Collaboration with us. That's possible. And we have a lot, at least 30 adjunct programs. We have also professionals to support us in our research activities and student training, and several postdoc and research assistant. Here the number vary each year. It comes for maybe 1 year, 2 years, 3 years, and they change time. Among the professors, actually we have 2 professors with background in geography, 3 or 4 professors with background in engineering, and the others are in physics. They have all background in physics. But our department is still located in the Faculty of Human Science. This is due to the history, because it started as a department of geography. And a few years ago, we tried to change, because it's not very easy for us sometimes to attract students. They even don't know that we exist, because students in science or engineering cannot think that there is a science department in the Faculty of Human Science. So they don't come to see us. We have to run after them to convince them to come to the department because we are doing science. They don't know. That is the real problem. We try to change. We try to go to the Faculty of Engineering or the Faculty of Science, but due to political issues, couldn't. Because the Faculty of Human Science didn't want us to move away. We bring a lot of money in, a lot of research money, so they don't want us to go anywhere else. Real problem. Okay, now let's talk about the PhD program in remote sensing. This program was created in collaboration with the Department of Electrical Engineering, located in at the university. It was created in '90, and actually we have over 65 PhD degrees completed in the department. If you look at these, all these graduated people, they are in Europe, in Canada, in Africa, in Asia. We have a few people coming from Brazil, from Argentina, from Vietnam, from Morocco, and so on, and Canada, France, Belgium, and so on. We have a lot of people inside everywhere coming to the university doing this PhD degree. Actually, we have about 30 active students who are continuing their PhD works. And the program itself is divided in 4 concentrations. The student can follow a concentration in physics of remote sensing if the objective is to develop algorithms based on physical models, physically based models, like radiative transfer model and so on. So people with a background in physics or engineering can follow this concentration. And the second concentration is about image processing itself. In this case, the people with background in mathematics, statistics, engineering, and so on can also follow this concentration. And the objective here is develop algorithm for image segmentation, for image classification, for pattern recognition, and so on. That is really the objective of the image processing concentration. We have also a concentration in applied geomatics, and this concentration is for people interested in GIS, Geographic Information Systems, develop GIS tools, models, and so on in Geographic Information Systems. And the final concentration is the application in environment. This concentration is not really very used by students because there are a lot of seminars to take here. You need to take the seminars in remote sensing and some seminars also in environment, so it can become very long. That's why it is not so interesting for students. And if you have any question, we can discuss, no problem. Okay, in each concentration, students should take 3 seminars for each concentration. And this is done at the first semester of the program, in generally in the fall, from September to December. For example, if a student is in the concentration of physics, he has to take a seminar in physics of remote sensing, in image processing, and in research methodology. These are 3 mandatory seminars he has to take if he is in the physics concentration. After that, he has to prepare a doctoral exam. We expect this doctoral exam to be done at the end of the second semester for a student who started in September. At the end of April, or end of April, May, June, we expect him to do his doctoral exam. And this is followed by a public presentation of the research proposal. Each student has to present his research proposal publicly. And a report on the data and the preliminary analysis. And finally, when the student is ready, he has his result, so he should do a public presentation of the results. All this is before the thesis, he said, before writing the thesis itself. The objective here is to have a jury member who can look at the result, criticize them, and give some recommendation to the students. He can, in order to let him complete some aspect of the research which are very weak. Okay? And when this is done, the student can write his thesis and submit it to the jury. Okay? And after that, it is the thesis defense. So here is how the program works. Okay. 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 How long it takes? All this. If we look at on average, students spend 5 to 5.5 years to do their PhD program. But a normal student, someone who is concentrated on his research, can do it in 3.5 years to 4 years. That is the normal duration. Why the average is so long? Because some students start their PhD work and get a job later. They continue to work and to do the PhD at the same time, and it becomes very long. That's one aspect. The second aspect is that some students come, but with a little background in remote sensing or geomatics. they have a background in another discipline, but not really very solid in remote sensing and geomatics. So they have to take some courses to have a strong background before continuing in their research. In this case, it takes also a long time. That's why the average duration is relatively long. Okay? And continue. Okay, the master degree is divided in two parts. The first is a research master, and the second is a professional one, professional master. Here again, we have approximately the same number of students as in the PhD degree for the Master of Research here. And we have three concentrations here. A master degree in remote sensing, even if the official name is Master in Geographical Science, but the student can follow a concentration in remote sensing, a concentration in geomatics, or a concentration in geography. Most of the students are here and in geomatics. We have very few students in geography actually, because the number of geography professors is diminishing each year. So we are essentially professor of remote sensing or geomatics. That is the reason. For the master degree, the student has to follow 5 seminars here. 3 mandatory seminars and 2 seminars options. He has the choice to take them. And here again, there is a public presentation of the research proposal. Each master student should present publicly his proposal, research proposal. And when the work is done, there is also a public presentation of the results. And after that, a master thesis can be submitted to a jury for evaluation. That's the way it works for our research program at the master level. And the normal duration here is 2 years. Okay? It can be 2.5 or 3 years for some students, but the normal duration is 2 years. Okay. The professional program is essentially based on courses. Okay? The student has to take courses. And there is also an internship. An internship. It can be done to the university. It can be done with a company somewhere, a private company, or with the government, and so on. So this is possible. At the end, we have to submit an essay, which is a kind of small thesis. But essentially, here, it is based on courses. Okay? My colleague Ramata here is the responsible of this program. And the program is given simultaneously at the campus of Sherbrooke, which is the main campus of the university, but also at the campus of Longueuil at Montreal, using distance learning facilities. Okay? The professor is at Sherbrooke, but the student can follow the courses when they are at Montreal. Okay. Yeah. Okay. Alors, the bachelor program in applied geomatics, I can say it is a relatively new program. New because it started in 2003 and replaced the bachelor program in geography we had before. The former bachelor program in geography was divided in 2 parts. A program in physical geography and a program in human geography. But all these disappear now. We have only this bachelor program in applied geomatics. In general, we take students with science background We can take also a student with human science background, but they have to follow some mathematics courses, mandatory mathematics courses before being accepted by the program. We have small classes, I can say, because the number of new students each year is around 20, 25 students. The particularity of this program is that it is divided in 3 main components, 3 blocks. The fundamental block is about the mathematics courses, the computer science courses, to give the background to the students. And we have the geometric blocks here where students take courses in remote sensing, in GIS, in cartography, and so on, geopositioning, all this stuff which constitute the geometric. And finally, we have the thematic block, because the objective here is not only to train people for geomatics. They should know why they are doing this geometric, who will use this geometric, and how it could be used. This is really the originality of this program. It is the only program of its kind in Canada. When we created it in 2003, there is no other program thinking like that. So this was very important, and this program is always very well quoted by the industry, because here in the thematic blocks, the students have courses in ecology, in geography, in environment, and so on, and they use their knowledge in geomatics to solve problems in all these areas. That is the important aspect of this program here. Can continue. And the program has some special features. The first one is a project-based learning. At the end of the program, the last 2 semesters. And this is, we base ourselves on the Faculty of Engineering, in particular the Department of Mechanical Engineering, who has the same type of project-based learning system. So this is very important in our case, because we organize the students in terms of groups of students, 3 to 4 students, and each group is considered as a small company, and should behave like a small private company. And they work on subjects which are given by different companies, real subjects, not fictive academic things, no. They work on real problems. These problems are sometimes given by the cities, the government itself, or the private companies. Okay? And they have to do all the steps. Okay? They have to write the proposal and to go through all the steps like a real company in the real world. This is the objectives of this program here. The second feature, important feature in the program here, is the cooperative internship. It is a co-op program. Co-op meaning that there is an alternance between the study sessions and the work in the companies or government and so on. The co-op is a particularity of the University of Sherbrooke and some other universities in Canada. In this case, it is the responsibility of the university to find an internship for the student. That's one point. The second point, the internship should be remunerated. The student should get money from that. These conditions are mandatory for the internship program. So each year, different companies, government, and so on, who has some jobs, some internship to offer, they come to the university and they interview students and choose their own student and so on. That is each year. And the duration is 4 months, a semester. So if we look at the program here, there is the regular one without any internship, okay, and the co-op program. Almost all the students are in the co-op program. First session, the second session, they take courses, and they come to the third session, which corresponds to the summer here, and they have their first internship for 4 months. And the second year, they come back to the courses, internship, courses, internship, and they finish the program with 2 sessions of courses. And here in these 2 sessions, session 5 and session 6, they are in the project-based learning system. Okay? That's how this program is really organized. And at the end of this, the students are considered as someone with 1 year of work experience. Okay. Okay, that is the particularity of this program. And so far, I can say that we are very, very happy with this program because we have students everywhere working in different companies, on the government, and we have always very, very good comments coming from all these areas. Rapidly, the bachelor program in environmental studies, this is a relatively new program. It started 3 years ago, and it is a multidisciplinary program. We have a number of courses under our responsibility in this program, but we are not the only department working in this program. The Department of Civil Engineering, the Department of Biology, and so on, all these departments contribute to the program. Okay. Okay, now we are continuing to work, and of course, we are always interested to develop international collaborations, and we will be very, very happy to investigate with your institution here what we can do together. And I know that our students are always very happy if they have to travel to come in countries like here. So that will be interesting. And it will be also a pleasure for us to receive students coming from here. And we are also working on the development of distance learning programs in remote sensing and GIS. Our real laboratory is the campus at Montreal, because we have some students there, and we are working on how to develop this distance learning, which can be followed by international students also. Okay. Also, one point also is the development of degrees in co-tutel. I don't know how to say it in English, but I write co-tutel. Maybe you can understand. It is degrees in collaboration. We have a lot of students coming in that framework with France, for example, at the PhD level. The thing is that the student will be graduated from the 2 universities. For example, if we work with IPN here, so the student will have a degree from IPN and the degree also from the University of Sherbrooke. There are a series of combinations like that which can be done. So this is something we have to explore together. Okay? Okay, that is done for the first part of my presentation. It is the main part because I think the objective of this conference was to show you what program we have and how it works. So maybe if you have questions on that, I will be pleased to respond, to answer.
Um, we are very interested in having some topics to be working in Cochutel. My question here is, what is the administrative procedure that we have to follow to establish this kind of collaborations?
Okay. We have a special service at the University of Sherbrooke who is in charge of all the collaboration, international collaborations. And they have procedures we can follow. It's a very well-known procedure for us. And maybe we can share the formulas and so on and look at what we can do. Also, there is one thing we have to check together. It is about the scholarship fees. Okay? Because when the student is at the University of Sherbrooke, he paid like a student at Sherbrooke. When he is here, he paid like a student at IPN or University of Mexico and so on. So we should look at those issues and try to see what we can do. And my own feeling is that it is important at the beginning to develop a kind of program, collaboration program, which can be funded by some Canadian institution like CRDA or SIDA. So in this context, we can have scholarship for students. I think that's the most important point at the beginning. Because yes, if the student wants to go, but if he has not the money to pay, that will be a problem. So we have to think about all this and come up maybe with a proposal together and submit that proposal to an institution like CRDI or SIDA first.
I am interested if there exists a relation between the European Space Agency. What is the project that's in relation to your university and the ESA? In particular, I'm interested in Vexus Nexus programs in Europe. If you can talk about that.
Okay, we have really a relationship with European Space Agency through different research programs. For example, we are involved in the SMOS. SMOS is a satellite for soil moisture and ocean salinity. And we are involved in the validation of this satellite as the only team in Canada, the validation team in Canada. And my colleague here, Professor Ramata Magaji, is the responsible of this program. We are in touch with different people like Professor Jan Kerr. He's not a professor, he's a research scientist, who is one of the main research, major research scientists in the European Space Agency for, at least for remote sensing side. And we know a lot of people there, and we have always connection with them because we need to have data from new satellite and so on, and we are always involved as validation or calibration teams and so on. This is really in always ongoing efforts. So, no problem.
What I want to add is that we have an agreement between University of Sherbrooke as an agreement with IPN and UNAM. That it is, I am not sure if it is just for research, or it is just for research, not for the academic program. Okay, but I think that it can be easy also to the academic program. I am not sure.
So these, the geomatic programs that you develop could be used, or are these used in the modeling the programs for climate research? Yes, that's my idea.
Oh yes, because geomatics can be used in climate research in different ways. For example, the integration of all the data set through geographic information system, the organization of databases. You need geomatics to do that very well if you want to do it. So that is a first point. The second one is today, if you want to talk about climate research, you cannot forget or close the eyes on remote sensing, because it is one of the important tools to use for climate research, because you have a synoptic view of the Earth, and you can monitor several variables, including soil moisture, for example. This is something we are working on with, in collaboration with Alexandro, and albedos and so on. All these parameters needed by climate models, a lot of them can be retrieved using remote sensing and GIS combination. So yes, the student I can say at least 1/3 of our PhD students works in the area of climate and climate change, using application of remote sensing and GIS.
For example, one question that could be answered using geomatics would be the influence of the clouds, in each little piece that forms the complete climate model.
Yeah, and there are special dedicated satellites for clouds, like CloudSat and so on. And it is the role of remote sensing pupil to derive information, to derive parameters from such satellite. And this information will be used later by people working on climate change, on over climate issues, like you are saying. So yes, I think there is a strong collaboration between all these communities.
And what I can add is that in our department there is one professor who is working also on cloud and atmospheric problem.
Okay, if you permit, I will quickly show you some of the research activities we are doing very rapidly, if you want. And we can go to the second part. Yes. Yes. Continue. Okay, so I come back to our research center. The real name is Centre d'application et de recherche en télédétection, and the nickname is Cartel, not for drugs, but for remote sensing. Okay, and we have also a chair, which is a Canada Research Chair in remote sensing, and donc in Earth observation and ecophysiology. And my colleague Yannick Hiot is the responsible for this chair. The Canada Research Chair program has been initiated, I will say, some 15 years ago. And the objective is that the government give funding to researchers, to research scientists, very good research scientists, and to develop research in specific areas. And our department has a chance to have one of these research chairs, which is the research chair in Earth observation. And also, all those professors in the department are not really members of the research center, because the condition to be member of the research center is to have at least half of your research in the area of remote sensing or geomatics. But we have some people who are not really working in these areas, but they are conducting their own research also. Okay, you can continue. Here is the research on land management, transportation, road securities. This is done by my colleague, Professor Linda Belalite, and she is a geographer, so all her research is in the area of geography, not in remote sensing or GIS. Okay, continue. Alors, this is the research of Yannick Hiot in the framework of the Canada Research Chair. The objective here is to understand, model, and observe the production and increase and variation of phytoplankton. Yannick works on lakes and oceans. He is an oceanographer, but working with remote sensing tools. He has a very good laboratory to do that, and we receive a lot of funding from the government. So he instrumented a lot of lakes where he can take automatically data for phytoplanktons and and other things. So his research is really in that area. So if you have some people interested in oceanography or lakes and so on, he is the one who can collaborate. Okay, we can continue. All these people is mostly concentrated on remote sensing. That is why we are the biggest research center among the universities. And one other particularity is that we consider all aspects of remote sensing. In other universities, you will find maybe someone working on a radar or working on LiDAR, but they don't consider all the aspects. In Sherbrooke, we work on from visible to the radar systems. All the aspects are considered in our research, and also in the training, on the training side also. Yeah, we can continue. So we have specialists in radar, like Ramata here, passive and active microwave. Myself is also working on this area. Optical data, LiDAR data. Donc, we have a colleague whose research is only on LiDAR systems, and spatial modeling, sensor development, and so on. And with application on different areas, including atmosphere, climate change, as I was saying now. Cryosphere is one of the biggest research area we have. Cryosphere is about snow, and it is also about ice. So we have a lot of research work on these. Forest, soil and agriculture, donc soil moisture, estimation using remote sensing means like satellite, the SMOS satellite, and the new satellite which has been launched by NASA just 2 months ago, and so on, watershed and so on. These are all the application areas we are working on. Okay? You can continue. Alors, an example here, Ramata was talking about one of our colleagues, Professor Norm O'Neill, who is his work is on aerosols. So he is interested in volcanoes, aerosols, and the transportation of aerosols and so on, how to characterize all this using remote sensing. This is the work of Professor Norm O'Neill, who worked a lot with NASA. He has developed a number of algorithms which are used by NASA, and he stayed there for a few years and has continued to have a lot of collaboration there. Continue. So all this is about the work of Professor Norm O'Neill. You can continue. The only photograph I have in my presentation is Norm O'Neill itself. And he has a lot of instruments installed in the north of Canada, because in this area, the Arctic, in the Arctics, it is supposed to be clean. But it's not always the case, because the aerosols are transported from Sahara, for example, and they go through the Amazon and so on. And I just read a paper on that saying that the aerosol transported from Sahara play a good role in the Amazon area. And I ask myself why. Because they say that with the heavy rains in the Amazon, the soil are lessivated and they lost a lot of nutrient. And some part of these nutrients are transported through aerosol from Sahara to the Amazon. So it's very complex issues. Norm O'Neill is interested by all these things, and they have a network of sensors installed in Canada and elsewhere all over the world. And he is one of the key persons in this area of research. I was saying that cryosphere is one of our active research area. And since the 90s, we are doing a lot of experiments on snow. Canada is a snow country. We have more than 2 meters of snow, depending on the areas. So it is important to know what is the quantity of water inside this snow. Because snow participates at least for 30% in the hydroelectricity in a province like Quebec. So it is very important for them to monitor snow and to know what is inside. But if you look at snow, you can think that it is something homogeneous. But this is not the case, because snow is composed of small grains, snow grains. And the principle with remote sensing is that the energy coming from the soil pass through the snow cover, and there is a lot of diffusion, dispersion of the energy, and the sensor in orbit measure this emission. So using that principle, we can try to know how the signal has been attenuated or diffused by the snow grains, and how we can estimate the snow water content using this principle. That's why we are doing a lot of works. And here we use plane, helicopters, all the means, possible means we can have to measure snow characteristics on the soil, and to use, for example, radiometers also to better understand snow on the soil before going to the satellite level. So this is why it's very important, and we are numerous researchers who are intervening in this area. For river discharge also, have to use remote sensing to estimate river discharge. This is also an important topic for us. Yes. And these last years, I will say 10 years, SMOS was launched in 2009, almost 5 years. There is a lot of activities on soil moisture estimation. And we are involved with Alexandro on these topics because it is very important for agriculture. It is very important for hydrology, for climate, and so on. Being capable to map soil moisture locally, regionally, and globally is very, very important. That's why special agencies like the Canadian Special Agency or NASA are putting a lot of effort, or ESA also are putting a lot of money and effort to be able to do it. But all these matters are very complicated. And in 2010, we conducted an experiment. This is in the west of Canada, because the terrain are very flat there, and so we are avoiding mountainous areas and so on. So we can do experiment and try to see how we can develop algorithm using that. And in 2010, we did this field campaign in the framework of the SMOS validation. In 2012 also, we did another field campaign for the SMAP validation, the new satellite, the NASA satellite validation. All these are international efforts. Sometimes we started the program ourselves in the university, but it became bigger and bigger, and we lost the leadership because because major players like from NASA and so they come with their planes and everything, so we become very teeny in the process. But we have a lot of data collected, important data collected on in order to develop algorithms for soil moisture. And it is important here that Mexico, in Mexico here, we have collaboration on this matter. That's why we will continue to develop things with Alexandro. It is very, because it is a complex area. You have the soil itself, you have the vegetation, or a forest, and so on. There are a lot of contribution to the signal, which is measured by the radiometers on board the satellites. So we have to, we must understand all these contributions before being able to estimate the soil moisture with acceptable accuracies. That's the challenge we have. Okay, we can continue. LiDAR is also an area where we are putting a lot of effort, both ground-based LiDAR and also LiDAR on board planes and satellites. Okay? The interest of LiDAR is the finest measurement they can provide. So you can reconstitute the topography, the structures, and so on. This is totally different from what we do in active and passive microwaves. Because if you look at passive microwave, the spatial resolution, the smallest units you are measuring is sometimes 25 kilometers by 25 kilometers. But with LiDAR, you have very detailed measurements. Okay? So you can reconstitute structures like this or this Aztec sculpture, you can do that using LiDAR. Right, you can continue. In Sherbrooke, we use LiDAR for forestry applications. Okay? My colleague Richard Fournier works on LiDAR, and he is oriented on forest. The objective is to estimate, to be able to estimate the wood volume inside the forest. That's one. And also the wood quality. Have the parameters estimated using LiDAR can be related to wood quality. That is a second aspect which is very challenging. Okay? And there is an aspect also about the reconstitution of the architecture of the trees. Okay? Because LiDAR measure is point measurement. You have a lot of points. Each time the point is, the light is reflected by the branches, by the leaves, by everything. So you can use all these millions or billions of points, try to reconstitute the structure you want automatically. That is the challenge for forest architecture. Can continue. For example, using this LiDAR system on the ground, and we have a former PhD student, François Coté, who developed tools in order to come up with this structure automatically using LiDAR measurements. Okay? These are very sophisticated algorithms, and with a lot of challenge. First, you have to do it 3 by 3, and after that, you have to maybe later see how you can represent a forest. And if they can do it, it will be very interesting for us, because Alexandro has this problem now. He is using a model, active microwave model, and he needs to describe his trees, the branches, how the branches are related, the trunks, the angle of all these branches. He needs that information, but he don't know how to get it. If these people can do this kind of work, that will be very, very interesting for research like Alexandro is doing. Alors, here it is an example of research in the development of algorithm for image processing. The objective is pattern recognition. The objective is to identify features like, for example, buildings and so on, using very high resolution satellite data automatically. Okay. This is one of my former PhD students who developed an algorithm to extract building information automatically from very high resolution images. So I have different students working also on this area. And we have also some professors, Professor Beignet, Professor Dongchen He, who works on the development of GIS tools, GIS models, image processing, and so on. Professor Beignet has now founded his own company because with his student, he was able to develop a lot of tools for image processing, and they transform it into a company. The university permits that, allow professors to do this type of thing. So his company is running, and he has a lot of people working in it. He continues to give his courses as professor also. I have a colleague who is a biologist. His background is in biology, but his PhD is also in remote sensing. He is interested by wildlife habitat, monitoring wildlife habitat using remote sensing, different techniques of remote sensing. For example, how to characterize, how to classify lichens, And lichens are used by some type of animals as food. So you can establish a relationship between all the circulation of these animals and the natural resources. So this is the type of research he is doing. Okay. Okay, donc there are other researches. This is just a general overview of what we are doing. And in terms of facilities, we have a research laboratory which is outside the university. It's just behind the university in the forest. We have a building inside which we have a lot of sensors, and it is possible also to design some experimental work, research in this area, and proceed. We have a laboratory of spectroradiometry where we keep our sensors. We have different sensors, including sensors in the microwave, L-band, and so on. We try to purchase, if possible, all the needed sensors, LiDAR, microwave, and so on. We invest a lot of money to do that. A laboratory of environmental analysis and a lot of facilities also for image processing, GIS, and so on. We need all that in order to do this research. Okay, donc that's it. If you want to have more information, you can visit our websites. Thank you very much, and I'm ready to respond to questions if you have one.
It's very interesting what you are presenting here in the different slides. And it's very interesting for us as an institution because the remote sensing is not a topic that is too developed in Mexico. We're still at the baby steps in some areas of the remote sensing topics. And we have some work done already, especially in terms of computer science and image processing, but we are really at the basis. And I think this is a good opportunity to start a collaboration, not only in research topics as we have now, but also for human resources in terms of students, in terms of some kind of exchange of students, and maybe to do some courses here and other courses in Sherbrooke. That's another issue that we have right now because we don't have a lot of specific courses that you have in terms of remote sensing. Maybe until now we are just teaching generalities in terms of what is satellite image, but to go inside some particularities in terms of what the satellites are collecting, it's not too difficult because of the background that we need. And I think it's a good opportunity to have a very good collaboration with you, maybe not only with this institution, but with other institutions in Mexico.
Yeah, this is a very good comment, and it is also my feeling that you will gain in collaboration. But first of all, I think it should be very interesting for you to try to regroup all your forces in remote sensing to try to come up with a kind of center also, like we did. Okay, maybe you have some specialists in different institutions. You can try to see if by regrouping all these people, you cannot create a kind of center like we did. That will be a good starting point in order to develop remote sensing. I think the real strength for us is that we create this center and we develop this center by keeping in mind that remote sensing is a small discipline But in fact, it is also a large discipline in some point of view. Okay? You have different aspects on these. And if you don't regroup all these aspects, so you can just work on a small part of it. So, my feeling is that if you want to be very strong in this area in the coming years, you should start by creating a kind of center. And if you have this center, the collaboration will be very easy with other centers like the ones we have. Okay? Because actually we have a collaboration just with you, and it can be collaboration center to center. And that will be very important. This is my feeling on that. Okay. And you have the capability to do that.
In order to work on the project for my PhD studies, I was reading about the Little Ice Age, and I found an article very recently who said that they used a climate model, the CCSM3 model, and put initial values on aerosols from volcanic eruptions. So they saw that in 4 of the results, in 2 of the 4 results they got that the ice sheet grew, and in 2 of them the ice stayed that way for hundreds of years. But they do not explain what variables. They just say that because the ice is very sensitive to other columns of water in the ocean, they lose that ice sheet after 30 years. Could you tell me if you know, after all this research on the ice, if we could say which variables are the ones that are changing that result? If yes.
I'm not working myself on ice issues, so I haven't read this paper. I don't have any idea of what is going on that. But if it is about aerosols, for example, I think you can get in touch with my colleague, Norm O'Neill, whose research is on aerosols. Maybe he could give you some explanation. But myself, I cannot say anything because I never look at ice. Snow, yes, but not ice. No problem.
Thank you.
Thank you. Could you please talk about MITAX program?
Okay. MITAX program is a scholarship program. It is a program where they can fund students. It can be not only the Canadian student, but students from foreign students, like, for example, from Mexico. And they have different programs for undergraduate students and graduate students and postdoc students also. And for example, for undergraduate students, they finance an internship for very good students so that they can come to Canada. If they are at the end of their program, they can come to Canada and work with a professor for a period of 4 months. And after that, they can return here. The objective is to give them a chance to work in a different environment, on different topics, different research, and so on. And for the graduate program, it is the same idea. But the difference here is that the industry, say, for example, private companies and so on, should finance one part of the scholarship, at least I think half of the scholarship. And again, the foreign students are admitted in this program. And the objective also is to permit them to work in the industry and also to the university and gain experience. In fact, after that, these students can come to Canada to do master or to do a PhD if they want. But the idea for the Canadian here is to open all the sectors, all the research sectors to foreign students, not only to Canadian students. Don't have enough. So it is important to open. And it is the same for postdoctoral students who wants to go in Canada. Simply get in touch with professors and so on, and they can submit a demand to this program, and so that you can, maybe for students, they can get some funding and travel there. So I think it is a very important program. And in our collaboration, this is something we are also looking at. We want to see what we can do with such program. You are talking now. You are talking with how to say it, to the exchange of students between our institution. That can be a way to do it, because we need money to proceed. Okay? So, but we can continue to look at all these things together.
Si gustas, Alejandro, traducirle algo. Bueno, voy a hablar y te traduces. Estas dos presentaciones nos ilustran un gran tema que en México, yo diría, no tiene gran desarrollo. La geomática, la percepción remota, por lo que conocemos son las entidades de gobierno que hacen aplicaciones, ¿verdad?, de la percepción remota. Pero de los planes y programas de estudio desde licenciatura, maestría y doctorado, los que yo recuerde, en México de manera específica no hay una institución que aborde el tema de formación. Pero que sí, de los diferentes ejemplos de investigación, pues México no escapa de toda esta gama de aplicaciones. Tenemos volcanes, tenemos inundaciones, tenemos sequías, tenemos incendios, tenemos una variedad, ¿verdad?, de eventos que hay que estudiar, analizar, y obviamente este campo y esta disciplina nos permitiría estar más cercano a lo que hoy en día le llamamos mucho lo que es la prevención de desastres. México es vulnerable a todo ello, pero yo diría que todavía nos falta mucho por aprender y sobre todo incursionar en el mundo de la aplicación de la geomática. Nos deja una gran reflexión su plática. Tenemos que emprender acciones las instituciones educativas. No se diga aquí el mensaje que lleve la compañera de la Agencia Espacial, porque sin duda eso nos permitiría, ¿verdad?, estar en un escenario de pertinencia a los sucesos, sobre todo que suceden en México, ¿verdad? Y por otro lado, pues la gran oportunidad que tenemos de colaboración, pues hoy en día se nos pone un ejemplo a través de esta universidad, pero sin duda debe haber otras tantas más que también tienen esa oportunidad. Entonces, vuelvo a insistir, nos da esa actitud de cosas que pudiésemos hacer de manera conjunta las instituciones, porque una sola no lo haría. Aquí estaríamos en un futuro cercano platicando con el doctor Monsiváis para emprender acciones concretas, sobre todo de colaboración con la universidad. Pues si no hay una pregunta, ¿verdad? Agradecemos a los que nos siguieron la conferencia a través de YouTube en vivo y agradecemos la conferencia del doctor y a nombre del Instituto Politécnico Nacional y el director del Centro de Desarrollo Espacial, el ingeniero Sergio Viñals, las palabras y el mensaje que nos deja el doctor Goïta. Thank you. Pequeño presente del instituto and your collaboration. Y a todos ustedes, pues gracias por escuchar al doctor. Y nos vemos próximamente. Gracias a los que nos vieron por el canal de YouTube. Buenos días.
Thank you very much. Thank you. Really a very big pleasure.